Many people who already have solar panels have got an inverter, but they want to expand the capabilities. They may find that if you want to add new batteries, for example, that those batteries, particularly the cheap batteries, are not compatible with your inverter. Certainly for my house, I have got an 8 kilowatt Solar Edge inverter. They are only compatible with Solar Edge batteries and LG batteries. If you want to get the cheap batteries, you need to have a second inverter. Now, for those people who haven't seen my previous videos, my name is Anthony. I own a 9 kilowatt solar panel array up here in Aberdeenshire, Scotland. I've got many videos which have described the technical and financial performance of my solar panels, my batteries, my heat pump, and also my car charging experiences. But in this video, I want to talk about the G99 application process. If you have already got an inverter, you will need to go through the application process again in order to add a new inverter in order to accommodate those new batteries and maybe expanded solar panels. So the G99 application process is relatively straightforward. If you have generating capacity greater than 16 amps per phase, which is 3.68 kilowatts in most instances, then you need to apply for permission before you connect to the grid. And this is done using what's known as a G99 application process. If it's less than 16 amps per phase, you don't need to apply to connect to the grid. You only need to notify using what's known as a G98 form. So this is a 2-page form for these kind of situations where you're talking about less than 15 kilowatts for a single phase installation. Now you've got generator details, i.e. your name and your address, and you've got the details of the installer. Now in this instance, I have said to be determined for the installer. If we go on to the technical side of things, you want to show what you've got already and when it was installed. So we've got this Solar Edge module, and then we've got a manufacturer's reference number. Then we've got the details of the proposed additional generating unit. In this case, we've got a SunSync inverter with 8.8 kilowatts, and we have got a manufacturer's reference number as well here. So that's it as far as the G99 application form is concerned. You need to also supply a schematic diagram. I'll just show you what that looks like here. This was made by myself. It's 2 pages, 1 page with notes and 1 page with the actual diagram. So this has gone through several revisions, but basically we've got the main distribution board, consumer unit. We've got an emergency power system distribution board. You can see what's existing and what's new. We've also got a consumer unit in the shed. So basically my proposal was to include an inverter in the shed with 2 feeds, one connected to the grid and one connected to an emergency power system changeover switch. So that emergency power system changeover switch will be able to supply your regular household loads, including your heat pump and your cookers, your fridge, and your lights and sockets and so on. So your main board, anything that was not on the emergency power supply, would just basically be the existing Solar Edge inverter and the EV and of course the shed. So that was the proposal. That was what was sent to them. And what came back was quite interesting. So the response from the G99 application eventually ended up settling on a discussion about the voltage limit at my house. And what they are saying is that voltage limits cannot exceed the 2.3% limit and export cannot exceed 1.3%. I don't know what this 2.3% limit is a limit of. In the UK, we have an official voltage, which is 230 volts. If you apply 2.3% over and above 230 volts, you still have a legal voltage limit. Let's go to this page here. you can see that officially it's 230 volts minus 6% plus 10%. So that's between 216.2 volts to 253 volts. So if we apply 2.3% over and above the 253 volt range, we end up with a voltage of 258 volts. And I've got a feeling that the 2.3% applies to 2.3% over and above 253 volts. So the question is, therefore, what historical evidence do we have of what voltages we have with the existing export limit regime? Well, I've got a graph that we can explore. This is for the 24th of June 2024. So it's not far off the longest day of the year. We've got export power and voltage. I'll just show you what the AC voltage looks like. Here it is. That's your voltage. So 248 volts was the maximum voltage that we had on the longest day of the year. As you can see here, this is produced power here, and this comes from the inverter. If you have a look at this graph here, this is your exported power. So you can see a lot of produced power was consumed on site when I was charging my car up in the morning. And then once the car charging had finished, that's when your voltage was spiking. We've got 5 kilowatts of export here. And it's during these 5 kilowatts of export, that's when you get your peak voltages here. Outside those export periods, so when I'm charging my car up, we're getting about 243-ish volts in terms of the supply voltage here. So it has to be over and above what the grid is supplying. Otherwise, you'll be consuming electricity from the grid rather than your inverter. So 248 volts at an export limit of 5 kilowatts. So that's what we've got, and this is what sets the. This is why we have export limits. It's to keep your voltages within legal ranges. Now we have what's known as a G100 requirements document. You can find this on the Energy Network Association's website. This is a technical requirements document for export and import limitation schemes. What I want to do is take you to page 15, which is design limits. And in here, we can see that we have got several different states which are defined. So we've got state 1, which is normal operation. State 2 is occasional excursion. And state 3 is failed conditions. Now, state 2 is essentially a situation where you have exceeded your export limit for short periods of time. In this instance, it's talking about periods of time less than 15 seconds. But we've got state 3 conditions, and this is what they were talking about in my email. They are talking about potential exceeding of 2.3% voltage limit. And in particular, they're talking about fault conditions. So they are talking about situations where your export limitation scheme has failed for whatever reason, and it's just pumping out the full capacity of the inverter straight to the grid. If we go back to here, we can see that state 3 is a situation where there is excessive export and the load and the devices are not constrained or tripped by the customer export limitation scheme. That's what CLS stands for. So in this, we've got design limits, and in the case of my property, the design limits relate to voltage limits. And it says in here, the worst case highest voltage cannot exceed 112% of nominal voltage. So in this instance, they're talking about 257.6 volts. And this is for low voltage supplies. So we're talking about any supply which is less than 1,000 volts. So this is what applies to domestic properties. So we have got fail-safe situations. And in particular, I have seen 15 seconds being the fail-safe limit for mode 2 operation. And in this case, mode free operation, that's the situation where you've got export limitation failure on both my existing inverter plus the new inverter. So potentially we're talking about export of 16.8 kilowatts. That's what the DNO is considering as the worst case scenario. And in that, they are saying, going back to here, that would exceed this 2.3% limit. So as we've seen with my existing charts here, 248 volts is what we have achieved with a 5 kilowatt export limit in place. If that export limit did not exist, I can easily, so if we were exporting 8 kilowatts, I could see this voltage here exceeding 252 volts, no problem at all. It would be right on the legal limit. But then when you add an 8.8 kilowatt inverter on top of that 8 kilowatt inverter that I've already got, then you can imagine the voltage exceeding 257 volts quite easily if export limitation failed on both the inverters. So this is a constraint which they are considering with the G99 application, and it's a valid concern. And these protection limits, they do exist for a reason. So I received a quote from SSE, and the quote was for £6,326.56 to the breakdown, and it is essentially final connection of a reinforced cable. So this should give you an idea as to how long my driveway is, looking the other way from where I normally plant my camera. So it's about 44 meters from the main cable underneath the street feeding my electricity supply point. So the quote is £6,500 roughly speaking to connect and supply reinforcement cable from the main cable in the street down to my house. And as you can see, that does not include excavation, and honestly I can imagine that being at least doubling the quote. This is the PDF document. It shows the approximate route of the existing cable. So the existing cable is a 35 square millimeter aluminium copper hybrid cable. And it says customer to carry out excavation, reinstatement, traffic management were highlighted in yellow. So in this instance, it only includes final connection. It does not include any preparation of a trench or backfilling of that trench and reinstatement of the driveway. Bear in mind, my driveway is shared with another property. So this is really, this is a lot of work just to add a new extra inverter. So the concerns about voltage limitation are very valid concerns which the SSE and network provider have. And their solution involves spending a lot of money on a new cable. Now, in my opinion, there are other ways of achieving voltage limitation in the event of a failed state. And what we have here for the heat pump is an electricity meter. This electricity meter it doesn't just measure the power consumption, it also measures voltage. And there are versions of this electricity meter which can supply a Modbus link, so you can get a lot of information from it. What can you do with a Modbus interface? Well, you can connect it to an ESP32 or a Raspberry Pi, and then you can use that Raspberry Pi to control a contactor, and then you can use that contactor to isolate your inverter. So in other words, you've got an independent means of protection in the case of overvoltage. It's quite straightforward to measure voltage. In the case of 253 volts being exceeded for more than 10 seconds, for example, 15 seconds is the statutory maximum. You can then command the breaker to your new inverter to be isolated. This is a very straightforward way of achieving protection using independent means. Now, I went to SSE Networks and I asked them, can we do this? And I've got no reply. From my perspective, this is a good way of doing things. Now, I've worked on emergency shutdown systems for offshore installations. That also includes process shutdown systems. And the key feature about these systems is that they are independent from the normal process control system. And they require all sorts of documentation to go with them. One of them is a safety analysis report where you have to calculate what the probability of failure on demand is for that system. And all of this is governed under an IEC standard called 61508. Which is it's a standard which relates to programmable safety systems. Yes, I think it would be an interesting challenge to come up with a test procedure which can demonstrate an independent supply protection mechanism. And I think that would be a much more interesting way of achieving the same solution. These guys want to do it the old-fashioned way, using a brand new cable with a lot of work attached to it. I want to do things in a more clever way, using a contactor and some independent measurements of voltage to act as protection. So that was my experience of the G99 application process. They'll never say no to you, but if they can't say yes, they'll give you a price. And that price will be something which is going to be so high where the chances are you're going to say no. In the case of my situation, the quote they gave me plus the anticipated cost of excavation and backfilling, that would more than double the project costs. So where does that leave me? Well, if you watched a previous video, you will know that my electricity bill for the whole year was negative. It was minus £150, despite the fact that I've got an electric car to charge and I've got a heat pump to run. So, isn't that mission accomplished? Well, yes, but also no. You see, I like hobbies, and I think this is a really good hobby to have. But there are options for me to consider. I don't need any permission to install an inverter here and supply my house, so long as I don't connect it to the grid. So I am talking about having an off-grid solution where you have a manual changeover switch where you can select a grid supply or an inverter supply, an off-grid supply for your house. You don't need permission for that because you're not connected to the grid, and therefore they've got no jurisdiction. That is an option, and I haven't considered that. But you may be then asking the question, well, if my electricity bill is negative, why would I even consider additional capacity? And it boils down to energy security. And you need to consider that there's two aspects to it. Number one, it's pretty cool to have your lights on when nobody else has got their lights on. But you need to consider what the risks are in terms of blackouts. Now, for my property over the last 15 years, there have been relatively few blackouts. We've had no blackouts at all this year, despite Storm Eowyn coming through in January. That affected the central belt and the west coast of Scotland much more than it did Aberdeenshire. But in previous years, we've had blackouts, but typically only 1 or 2 per year. They are not frequent. We're not talking about once a month for several days at a time. But there is a risk coming up in the next 15 years. Of course, there's climate change and more serious storms, but there's another risk, and that's war. And people are talking about the prospect of war looming ever closer. And in that risk of war, there is cyber warfare, which is going to be a very acute risk for the United Kingdom. There are plenty of people who want to disrupt our way of life in our country. And cyber warfare is a way of doing things without landing a single bomb in our country. That's a risk. I don't know how to quantify that risk, and I don't know whether it's worth investing in that risk at all. I think you're going to have bigger things to worry about if war does come to our country. But it's a thought to ponder. But aside from that, yeah, I think having off-grid supply is pretty cool. So I'm not saying no to this project just yet, but there's certainly no rush for it. So that's it as far as this video is concerned. Next video, I'm not too sure what that's going to be about, but I've still got a few things to discuss in terms of my solar panel performance, and in particular, things which look like faults. So we'll talk about that in the next video. So I'd like to thank you all for watching, and I'll talk to you again very soon.